Evening, everybody. A very warm welcome to all of you. I'm Yash here at Propagation Institute for Advanced Studies. We are delighted to have you today for another session of the Curious Mind series. Today's topic is space medicine, a new emergence in scientific field, which sits on an intersection of space science, biology, and human health, an area that is rapidly shaping the future of long duration space missions and life beyond Earth. The expert session is being organized in collaboration with SA Citizen Science Group. It's the largest citizen science group of India, which is also Sohan sir is present here, so thankful to him. At Propagation Institute for Advanced Studies, we focus on long-term scientific nurturing. Our programs guide students from school level to college, building strong foundation in space science, research thinking, and interdisciplinary learning. As part of this mission, we are also organizing an international space quiz competition of 2025 on 28th December of 2025, which is completely free organized online competition, open to all school students, especially from classes 5 to 10. We warmly encourage students and teachers, parents to participate. I'll show you a few things so that you can understand how to do this and how you can participate in this thing. Uh, just give me a second. I'll share my screen. I hope my screen is visible. Now, if you go to the main site and you see everything that is here, you'll see the Cosmic Researcher Program, which is for junior students, which covers a bunch of modules like astronomy, advanced astronomy, astrophysics, cosmology, everything that one needs to get into advanced things. And another one that is senior researcher. For the junior researcher program, there's a quiz competition so that you can get a bunch of scholarships and other stuff. That will be organized on Sunday 28th. So you can just, if you are interested in any of these programs, you can just click over here and a form will appear for you. And you can fill in your details and we'll contact you. Our team will contact you. All right. Now, if you want to do the quiz competition and you're in grade 5 to 10, you can simply click here and you can sign in. Let me just sign in. This is the one of those accounts. My bad. You can sign in and you can fill in this form. As soon as you fill in the form, somebody will contact you. You'll get more details on email, and you will be in there. Right. Now let me unshare my screen. Okay, that's all that I had to tell about this program. Now I'll introduce you to our today's guest. I am extremely happy to introduce him. He is an extremely kind gentleman. He has been very kind to us, and he will be kind to you. It's my honor to introduce today's distinguished speaker, Dr. Krishnendu Ghosh, an accomplished molecular and cancer biologist with interdisciplinary expertise spanning neuroscience, immunology, astrobiology, and space medicine. Dr. Ghosh is currently a postdoctoral research scholar at Carver College of Medicine, University of Iowa, USA, and a visiting scholar at Drew Marble Space Institute of Science, Seattle, USA. His research preserves molecular biology, cancer research, and astrobiology, offering valuable insights into species in extreme environments. With more than 20 peer-reviewed publications, multiple book chapters, editorial responsibilities, and prestigious national and international recognitions, Dr. Ghosh exemplifies scientific excellence and interdisciplinary vision. With this, I invite all of you to stay curious, stay engaged, and actively participate in today's session. Please join me in warmly welcoming Dr. Krishnendu Ghosh to deliver today's talk on space medicine, a new emergence in scientific field. Thank you, sir. The mic is all yours. I'll pin you to the screen.
Thank you so much for your kind words, and thank you so much, the Propagation for Advanced Studies, for this opportunity. I'm really grateful for that. So let me share my screen first. Is it visible now?
Yes, sir. It's visible.
Okay, fine. So, hello everyone. This is Krishnendu. As he mentioned earlier, I'm a postdoc fellow at the Department of Pathology, Karwa College of Medicine, University of Iowa. My primary research is cancer biology and different kinds of molecular signaling that is involved in the cancer biology itself. And apart from that, I'm also specialized in immunological and neuroscience research. But along with that, I'm pretty much interested in space medicine and astrobiology. And not only interested, I'm literally trying to keep this as my parallel mode of research in this area. I'm a visiting scholar in the BMSIS Seattle doing some research in space medicine and astrobiology. And I'm a public speaker, mentor, orator in this field also. So before proceeding into this one, I would like to make this not only an entire kind of orientation dedicated to space medicine, but at the same time, how I got involved into this space medicine and astrobiology, although being a student of biological science itself, that would be another part of the story that I would like to amalgamate in this presentation. So this is a kind of first slide that I'd like to show you. How many of you actually had a dream of this thing, or were in a position to think of that one day you will be becoming an astronaut, you will be becoming something that you will travel to outer space, you will be enjoying lots of glimpses of spectacular universe, you will be a space traveler crew member. How many of you? I believe most of you at least. And for me, it was pretty much obvious because since childhood, the space has been my crush, to be very honest. But in course of time, when I shifted my gear towards the biological science, because that was also prudent for me, I sometimes had a kind of thought, and I was kind of in this position. So, okay, I'm now in hardcore biological science, and the space science is not going to affect here, and I'm not in a position to pursue my study in the space science anymore. And obviously, I mean, no offense, there are certain persons, there are certain tentative thoughts and pretty orthodox kind of thoughts that, oh, you are from biological science, that you have nothing to do with the space science and you cannot do anything. Because to be excel in space science, you should be having a strong physics background, a strong mathematics background. Obviously, it's true. But somehow, these kinds of talks literally made me pretty sad. I thought, okay, let's just continue with the biological science because that's also my love also. But maybe not in this lifetime I'm going to see anything about the space science. Maybe in next lifetime I'm going to do something for the space science. So that was my thought until I got introduced to this particular person. So how many of you knows this person? And he's a kind of role model for me. The name of this person is Carl Sagan. The Carl Sagan was actually a physicist, planetary scientist, with a deep passion for amalgamating biological perspective into the space physics and astronomy. He was the first person who developed the idea of extraterrestrial possibility of life, who first developed the idea of having an institute entirely dedicated to the finding of life outside our own Earth. At that point of time, many of the scientific community members used to see him like a maniac, like a mad person. And the same venture was there that being an astrophysicist, why he is so much enthusiastic in this particular part, which is absolutely rubbish according to them. But gradually, and thanks to him for his generous idea, an entire new field of science actually evolved. And that field of science is known as the astrobiology, where you can think of the biological science in cosmic perspective. And to honor this person, now the SETI Institute, I think many of you have heard the name of SETI, the Search for Extraterrestrial Intelligence. The SETI Institute, there is a top tier respected chair in that institute known as the Carl Sagan Chair. And that's the kind of respect that this man actually earned. But he thought differently. And when I came to know about his research, about his thought processing, I talked to myself and I just asked, okay, let's give it a try. I mean, he paved the way, and all I need to do is to go into that direction, follow his footsteps, and let's see what happens. So, being an astrobiologist in condition, we need to think of different perspectives, obvious related to the life as well as in cosmic arena. Now, let me show you an interesting picture. Now, can you tell me that what is the most common thing that you could see in these three pictures? If you like, someone can unmute yourself and you can say, what is the utmost resemblance among these three pictures? Anyone? Please feel free to unmute yourself.
Parents and their kids.
More precise? Almost there.
They looks the same.
Anything else? Okay. They're all
Actors.
star kid, right? They're all star kid. And we always think, okay, these are the star kid. They're having a kind of glittering lifestyle, and we don't have the way of things that they are going to enjoy in their life. It's not going to happen in our life. See, from this day on, you should think yourself that all of us are the children of the star. So there is no specificity that these persons, they are only the star kid. We are all the star kids. Now you might say, why? Because think about the Big Bang. Think about the Big Bang story. There was nothing except the hydrogen gas cloud. And after successive stages, all the life evolved in the earth. So from the initial stages of Big Bang to the formation of the galaxies, formation of the solar system, and thereafter the formation of the earth and the life form. And this life form means us. So how we got evolved? We evolved from the star. So on that note, being the inhabitant of the third planet in our solar system, definitely we are all the kids of star. We are all the star child, isn't it? So from today's onwards, think yourself, be proud in yourself, and just think loudly that we are all star kids. Now, whenever we are talking about the astrobiology means the understanding of the origin of life, how life evolved in this earth, and eventually, at the same perspective, is there any kind of possibility of life outside our own earth? If there is, how to detect that? How the life thrives in the extreme space condition? What are the odds of getting life in different celestial bodies? How to detect them? How to go there? How to measure the units and the building blocks of life? These are all the connotations of astrobiology itself. But today's talk is not directly focused on the astrobiology, because definitely astrobiology is the first field of science that amalgamated biological science with astronomy. But when there was a bloom in the astrobiology, people thought, okay, so whenever we need to explore the different kind of celestial bodies, we need to travel there. The astronauts were ready. They were being taught how to different kind of space condition are going to affect on your body, how to thwart them, everything. But even after that, there were numerous conditions that are still responsible for various kind of obnoxious effect in astronauts' health. So it's a kind of branching of the crude astrobiology itself, specially dedicated towards the astronauts' health during the space traveling missions. And thus, the field of space medicine came. How you are going to amalgamate the conventional study of medicine with the astronauts' health, with the space travel, and all the other means by which you can do good kind of justification, and by the virtue, the astronauts are going to be that much of efficient for the space traveling. Now we know that the conventional medical history branches from the ancient Egyptian and Indian origin through the courses of Charak and Shushruta Samhita, and thereafter the cutting edge medical therapeutics and precision intervention in current scenario. Now, how we can incorporate this knowledge of medicine into the space orientation? Typically, in theory, the space medicine, according to the Merriam-Webster dictionary, is a branch of medicine that deals with the physiological and biological effects of human body during the space flight. Obviously, because space, as we know, is not a pretty healthy region. So when we want to discuss anything, any new subject, any new topic, there should be a kind of history. And the history of space medicine literally started with this gentleman, the Strughold. So Strughold was a Nazi physician during the World War II. And after the World War II ended, there was a mission governed by the US government. And the name of the mission was Operation Paperclip. And what was the mission? It was a mission to collect all the brightest minds from the Nazi community into the US and foster their genius brain for the development of science and technology here. That's why it's a kind of paperclip. We know the paperclip tends to bind all the pages in one place. So Dr. Strughold, when he came to US, he was the pioneer professor of space medicine at the School of Aviation Medicine in Texas. And literally, he can be regarded as the father of space medicine. So originally, the idea of space medicine was not that much young. But the thing is, people hardly cared about that. Another landmark thing in the field of space medicine is the Sputnik mission and the famous Laika, the dog. He was there in the Sputnik mission, and for the first time, the space mission was there with a living biological organism. And that was a kind of thing that actually made all the scientific community to think, okay, biological organism can sustain in the space condition, provided that they are going to have the proper orientation for their sustainability. And finally, the famous Apollo 11 mission, the first orientation of human space mission in any other celestial planet, celestial bodies to be precise, apart from our own Earth. After this thing, the space mission, manned, unmanned, and non-human space mission were started to escalate. And different kind of organization across the world, like the NASA, JAXA, Roscosmos, ESA, including our ISRO, they just geared up themselves for various kind of manned and unmanned missions. And not only that, various non-government private sectors like the Axiom or the SpaceX, they also joined the milieu. So gradually, this entire scenario of space medicine research got a nice escalation from hereafter. Now, this is a kind of so-called division of the space medicine, and I would like to consider these two vital arms of space medicine, the primary arms and the secondary arms. The primary arms is pretty straightforward. How to address different kinds of conditions that astronauts is going to face during the space adversities, and how to protect an astronaut from those. This is the clear-cut orientation. And the second one is the secondary approach. How we can interpret those kind of conditions and if they are helpful for mitigating any Earth-based disease condition. If we can take something, some aspect from that, and we can interpolate those things in the space-based condition into the Earth itself. So that's the secondary condition. So this one is pretty straightforward. This one is a kind of bending. So let's talk about the primary arm first. Whenever we see that the astronauts training are there, they need to go an array of training methodologies, an array of modalities to get qualified for any kind of space mission, because they should be pretty much prepared for all the space adversities. So we can think that, okay, they are having a huge fun here. They are going to be having a pretty prestigious life hereafter. They would be having the notion of astronaut before and after their name. But it really comes with a price. Why? Because the space condition is having huge types of atrocities, ranging from the microgravity, galactic radiation, extremely low temperature, low oxygen for obvious reason, and also the isolation that an astronaut is going to face during his or her space traveling days. Isolated completely from Earth, isolated from his friends, families, everything. So these are the things that are going to take toll on the astronaut's health. And if you can see this picture, this is a kind of astronaut's body, and you can see almost each and every part of his body is actually getting affected by any of these conditions. So whenever an astronaut travels into the space, every inches of the body will be affected. And that's the main motto of the space medicine, to identify what are the things that the astronaut is going to face and how to mitigate that. So let's talk about the microgravity first. So what is microgravity? The micro means small, the gravity means the gravitational force. Here in Earth, our body is quite equipped to resist all the gravitational forces in Earth, especially our bone, our muscle. Everything is quite equipped to face this because we are evolved in such a way. But whenever the astronauts are in the space condition, there is almost a zero gravity or pretty much microgravity in condition. And that microgravity is deleterious for the entire body, especially the bone and the muscle system. The bone, the muscle, the cellular condition, everything gets affected with this microgravity condition. And there are certain literature that suggests that deformities of bone, osteoporosis, loosening of the muscles, problem in the muscle cells and the bone cells, and even cancerous condition arising from bone and muscle. So these kind of conditions are usually taking place while an astronaut is in the space. That's why you might have seen that astronauts in the International Space Station, they should be undergoing into rigorous exercise regime to keep their bone and muscle health in a proper condition. So this is the only one, this is only the microgravity condition. This is one of the key aspects of the space atrocities. Now think of the high space radiation, because we know here in Earth, we are pretty much safe. Thanks to our atmosphere, thanks to our ionosphere, magnetosphere, ozone layer. These layers are typically the ambrosia of life. And we are being saved from harmful space and cosmic radiation. But there in space, there is no umbrella of atmosphere. So the astronaut's body is directly open towards the bombardment of various kind of highly energized particle, ranging from X-ray, gamma ray, cosmic ray, high charge, neutrino, everything. Although the space suit is quite capable to withstand a degree of space radiation, but that is not enough. Even the multiple layered space suit, also known as the mylar layer of the space suit, cannot protect an astronaut completely. That's why in International Space Station or any kind of space mission, there is a significant point of time when you can be outside your space station or outside your space shuttle. And after that, you have to come back into the space station itself, because there is a certain level until which the space suit can protect an astronaut from these heavy bombardments, but not after that. And these are certain chronic and acute effects, ranging from the pathological condition in the brain, central nervous system, cataract in the eye, increased level of cancer risk, different kinds of skin and dermatological problems, various kind of odd condition in the immune system, everything. So again, the space radiation condition is going to take toll on astronauts' health. Third one, extreme cold condition. Now we can think how cold the space is. Technically, if you convert that in centigrade scale, it should be close to around minus 271 degrees Celsius. Now, how you are going to compare this particular temperature of minus 271 degrees Celsius with anything present in the Earth? Let's compare with the liquid nitrogen. The liquid nitrogen is having the temperature of minus 196 degrees Celsius. And it's so much rugged in nature that if you dip a healthy, fresh flower into that just for a second and then take it out, you can literally crush the petals of the flower in no time. So minus 196 degrees Celsius is that much harsh. Now think about minus 271 degrees Celsius. How much harsh it's going to be. And this is also in comparison of different kind of temperature that a normal human body is sustainable. We know that the normal human body temperature is around 36, 37 degrees Celsius. And in a dead person, the temperature falls below 27 degrees Celsius. And in between that, there are different kind of pathological condition, with different kind of emotional condition that will changes the or fluctuate the temperature condition throughout the body. But the fluctuation level is only in between 8 to 10 degrees Celsius, and that could be fatal. Now think about the changes of temperature or the fluctuation of temperature in the space. It's so fatal. What is going to do? In the first step, a simple frostbite. And the simple frostbite means numbing of all the extremities of the body. Immediately, it will cause the frost nip. That means the redness of the extremities of the body, damaging the upper layer of the skin instantly. The third one is the frost blister formation. We all know that blister comes from the heated condition. But no, blisters can come in ultra frosting condition. And these are known as the frost blisters. And gradually this kind of lumpy blisters tend to form in the extremities. The upper as well as the middle surface of the skin get destroyed. And finally, the deep frostbite. All the layers in the upper, middle, and part of the internal layer, the subcutaneous one, they seems to get dyed, making the extremities black in structure. That means those are the necrotic or the dying tissues. And this can happen in couple of seconds in space condition. So from that, you can think how adverse the space condition is. Another constraint is the low oxygen in space, for obvious reason. And for the low oxygen in space, we might suffer into various kind of respiratory illness. We can literally think that in the absence of oxygen, even in Earth-based condition, we feel choked. Now think of the space condition where there is almost no oxygen, and if the astronaut's body is exposed into that, different kind of respiratory distress will arise, causing the death in a minute. And then the psychological stress. Because previously they were all the pathological and physiological stress, but we should not forget about the psychological stress too. Because due to the long isolation, confinement, disruptive circadian or the biological clock, everything results into the psychological problem of the astronaut. That's why after a space mission, almost each and every astronaut should be undergoing into long-term psychological counseling, or else their mental health will be pretty much destroyed. So this is another, and this is a kind of long-term scenario. So these are all the primary arms, and from this particular discussion, you can see that what are the adversities and what are the things that astronauts should be pretty much aware about this. Now comes to the secondary arm. How we can interpolate different kind of things that are happening in the space extremities and how we can translate those in Earth-based condition. It actually happened in terms of cancer, and this is pretty much evident. We know, and we just saw that how space condition directly related to the increased cancer condition in the space. Because whenever the body is exposed to extreme radiation, whenever the body is exposed to the microgravity, the risk of cancer will escalate. But here is a takeaway, that radiation is a mean by which the cells are going to get changed. And now think that here in Earth, we use radiation therapy to mitigate cancer. Now, if we can try to amalgamate these two things, then we can kind of think in a way that what level of radiation will be enough to make certain changes in cancer cells, and that will cause the mitigation of the disease in Earth. So the space condition is going to give you an idea that different degrees of level of the space radiation along with the graded changes of the cells. And we can translate that into our study, that how different gradings of radiation therapy can cause changes in the cells, especially the cancer cells. And similarly, we can manipulate those degrees, those levels, to make the best effect in radiation therapy without harming the adjacent normal cell in a cancer patient. So our medical system is currently trying to translate these space-based evidences into the treatment of the cancer. So that's why this is a kind of strong secondary arm in space medicine. At the same time, we saw that the space condition is pretty much responsible for various kind of neural and muscle damage. And this is also related to various kind of cognitive impairment. That similar way, we can think how this kind of condition related to the gradual changes of the cells, of the neurons, of the muscle, and similarly, we can make precise conditional medicine to cure neuromuscular, neurodegenerative, and cognitive pathological conditions. So this is another translational approach from space. So after this primary and secondary arms of the space medicine, there are some certain interesting aspects that are currently going on related to the usage of non-human models in the space biology programs. Like this squid. We know among all the invertebrate, squids are having the most achievable level of cognition, and they are pretty much clever. Now, a recent study is currently going on in the International Space Station where the scientists are observing how the space atrocities are going to make certain changes in the cognitional aspect in the squid. How their neurological circuits are going to play among this kind of space adversities. Also, when we are going to make lots of manned space mission, we'd be needing sufficient supply of food. And that's why a new field of science is currently approaching in the arena. And that is known as the space botany or astrobotany, where pretty resistant types of seeds are being cultivated in the space-like condition in International Space Station, at the same time in Earth-based simulative condition. And from that, we can have proper food for the astronauts for future space missions. So these are all the new approaches. And since there are lots of students here, I can suggest that these things are the future. So if you are from this different field of study, you can definitely think of contributing directly into the space science because the changes are here. And obviously, there are some certain platforms where you can do this kind of biomedical research, because you should be having proper platform to do this kind of research in space medicine, in astrobiology, in astrobotany, everything. So in Earth, we are having this kind of microgravity generator. And this is a small but really, really costly machine. And this machine can generate a 0 to microgravity condition. And here we can place the cells and we can see how the cells are going to behave in this microgravity condition. Also, there are lots of researches that are going to that are taking place in the International Space Station. In near future, the Axiom is going to make the first commercial space-based lab where you can literally buy some hours of space and you can do your research stuff there. Good news for India that India is gearing up for making its own space station. Eventually, the first phase is going to happen by 2035, but the final shape might take 2040 or 2042. So these are the next generation space-based labs where there will be a different kinds of space medicine, astrobiology, astrobotany-based research that will be taking place. And again, another good news for the Indian perspective, that Indian Space Research Organization has recently signed a MOU with the Department of Biotechnology, Government of India. And we can think that in near future, India is also be preparing for various kinds of space-based medicine, space biology researches, and astrobiological perspective. Okay? So if you think globally that where you can pursue the space medicine research and at the same time space medicine master's program, there are some certain universities, although very, very low, a few in number, they are pretty good, like the Baylor College of Medicine, like the German Aerospace Medicine Center, University of California, Los Angeles. They are having their dedicated space science department amalgamated with the biological research. If you want to know more about the space medicine, there are some numbers of books that you can look into, and it's a kind of joyous moment for me to announce here that me, along with my wonderful friend Debjoy from New York University, we are editing a book currently, and if it is going to take its original shape, then it would be one of its kind, because it should be having more than 50 plus chapters in that book. And I think it will be a great resource for the future space medicine, and the future generation will be pretty much benefited from this one. So to conclude, you can think of my earlier slides when I was pretty much sad during my early college days that I might not be able to contribute myself into the space. But now this is me. Why? Because on one scenario, I'm pretty much happy with my cancer biology and immunology research that I did in various prestigious platforms. I got my PhD from University of Calcutta. I was a faculty member at the Ramakrishna Mission Vidya Mandira, Belur Math for a long period of time. Currently, I am a postdoc fellow doing cutting-edge cancer biology research at the University of Iowa. And parallelly, I'm an astrobiology and space medicine research personnel who first took its flight from India-based Spacenova. I was there as the head of biological science division. Then I joined the Blue Marble at the Seattle. I'm also a member of the NORCEL UK and also regularly contributing to their network of astrobiology and astrochemistry. And obviously, more is definitely getting loaded. So in near future, I think I'd be more than happy to contribute more things in these arenas and ultimately into the mankind. So to conclude, this is my very, very much a remark that is pretty close to my heart by Stephen Hawking. Remember to look up at the stars and not down at your feet, because whatever things you want to achieve, whatever things you want to see as your dream, and whatever the dreams that has to come true in your life, you should be pretty much upheld on that scenario so that one day your dream will definitely come true. So with that, I would like to rest my talk here, and I'll be more than happy to take some question. So thank you so much for your patience.
Thank you so much, sir. We'll take questions now. People who have questions, you can raise their hands, and we'll take directly from you. Or I strongly suggest you do that. If not, if you're too shy, you can paste your questions in the chat box itself. That would work out. But I would suggest do it via your mics.
Sure.
Do we have anybody?
Hello, sir. How are you? Hello.
Good, good. How are you? How are
I'm
you?
fine. Sir, I have a question.
Mm-hmm.
Sir, we know that bone loss occurs in microgravity and
Right,
muscle atrophy or dystrophy is also commonly observed.
right.
Are these changes completely reversible once astronaut return to Earth?
If the astronaut is going to get a complete uh, exercise schedule with some proper medicinal conditional thing and I mean kind of rehab, a complete rehab kind of thing, if it is not 100% reversible, it might be at least 80%, because the astronauts usually perform a very scrupulous level of exercise regime during their space mission. So that is going to save the astronauts in some way. And the remaining part of the loss that they are going to have for sure, that can be reversed at least to some extent by the therapeutical as well as the rehab approaches.
Okay, sir. Thank you so much.
Okay, thank you.
This session reminds me of the days when I used to study with your guidance.
Thank you. It's my honor. Thank you so much.
Welcome, sir.
Thank you, Arpan. We have Alan here. You can ask your questions, Alan.
Sure, Alan.
Hello, sir.
Yes.
Sir, I wanted to ask if you are growing plants and keeping animals in space,
Mhm.
won't their growth be affected by the radiation and the surroundings?
Obviously, they will be. That's why you cannot put anything in an open space condition. You have to make a proper kind of setup, just like we make the aquarium, just like we make the terrarium. You have to make a proper arrangement for them. You have to make a pretty good condition where you can grow the plants. You have to maintain a proper condition where you can raise the animals. So definitely it will be a kind of artificial thing, artificial condition, but it can be done.
Sir, so we have to give the plants or the animals protection as we are protected, right?
Right, and to add into that, I can say that these particular plants are genetically modified, because when you are going to make the seeds of these plants, there will be certain incorporation of uh, resistant genes, and that will make these plants pretty much resistant to the space condition, so that they will be much more resilient than their counterparts in Earth.
But what if somehow some radiations by radiations they get mutated and by consuming that the astronauts get affected as well.
Obviously that can happen. That's why we have to be pretty much sure that we should be maintaining a proper condition, and that's the ultimate goal of this kind of biological feature of the in the astronomy. If someone is from astrobotany, he or she will be pretty much dedicated to make the best condition suitable for those plants and protect those plants from the direct radiational bombardment.
Okay, sir. Thank you.
Welcome.
Thank you, Alan. Do we have anybody else raising their hands to ask the questions? Anybody? Okay, I'll take questions from the chat. I'll read them out to you, sir, and you can answer them. Marcos asks, how does long duration microgravity alter cellular mechanotransduction pathways, and what implication does that have for tissue degeneration?
That's a great question. So definitely this microgravity obviously having a huge amount of changes in the mechanotransduction of the cells. It is going to interfere with all the ciliary structure of the cells. It is going to interfere with the cytoskeleton of the cells. It's going to interfere with the gap and tight junctions of the cell. So together you can think that in what way the cell's mechanotransduction will be impacted. So obviously, the microgravity in long shot is pretty much deleterious for the mechanotransduction of the cells. And for the mitigation, well, there are some levels of damage that you cannot control. But researches are going on how you can provide the best care for the astronauts. What are the regimes that astronauts could follow to minimize this loss, and the continuous training for astronauts in the Earth-based analog system? These are the things that might be handy in answering these questions. So definitely we need to wait for some more time for some more researches to come. And that's the beauty of this subject, because this subject is really, really naive in nature, and it's still in its learning phase.
The second question from Marcos itself is, what are the molecular mechanisms behind spaceflight's induced dysregulation, and how...
Immune dysregulation. Okay, fine. That's another great question. Obviously, there are huge amount of molecular level changes. Like a recent paper came from Nature that the long-term space flight might alter different kind of cytokines. There is a huge chance of cytokine storm in the body of astronauts if the body is too much exposed towards the space condition. Also, there are some polarization of different immunological molecules, say the macrophages or the microglia in our central nervous system. Because we know that microglia is the sentinel of our central nervous system. He's a protector, he's a brain macrophage. But usually there is a disease form of the macrophage, which is known as the M2, which is closely associated with the cancer and other kind of diseases. So it has been established that space condition can be a part of converting the healthy microglia into the disease-prone M2 phenotype. And when there is a huge population of the M2 phenotype microglia or the brain macrophages, it can cause diverse array of neurological problems. So the cytokine storm, cytokine signaling pathways, inflammation, changes in the cells of the immune system, the polarization of the immune systems, these are different aspects of immune deregulation in the space condition.
Does anybody has any more questions? We'll take them. This seems to be the end of our limit because the time is running out. Do we have any more questions, people?
I think Orpon has put another question. Is space surgery possible? That's a nice question. So this is a kind of call of the hour question, because currently there are some departments in some prestigious medical universities, and they are trying for space surgery at present in simulated space condition or in international space condition. And in our upcoming book, we also put this chapter as one of the potent contribution. And thankfully, we got someone from a very prestigious medical university who is willing to contribute into the field of space surgery. So definitely it is possible. Space emergency medicine and space surgery is a pretty upcoming field in the space medicine arena, and researches are going on. So in future, yeah, definitely it will happen.
Thank you so much, sir. Thank you.
Yeah.
Srinivas has a question. What about excretory system of human body in space?
So basically, in space condition, there is a pretty much limitation of taking fluids. So the astronauts are literally rationed of taking fluids there. So obviously, that is going to make a deep impact in the kidney system, our excretory system. And the type of foods that they are getting, the high protein contained food, definitely it is going to make a huge amount of urea and uric acid. Although they are prescribed, they are also prescribed with good medicine to break down that urea and uric acid. But even after that, after the space mission, all the astronauts usually faces this kind of problem, from hearing loss to excretory problem to muscle loss, everything. So they usually don't face anything during the mission, but once they come back into Earth, they start to face one after another. If we go into the space,
Then come back to Earth again. How much time will it take back for our usual mental health?
okay, that's another nice question. It depends upon your mental strength and ability. If someone is pretty much tough-minded, he or she can withstand the different kind of mental problem or the psychological hindrance during the space condition in less number. But if someone is pretty much emotional in nature, he or she is going to face a lot. So it depends upon your own mental health. Obviously, you will be going through a lots of training. But usually it has been recorded that a person, recently we know the case of Williams, that after a long time, almost few months, she was literally out of her mind. I mean, she was pretty sad. She was having emotional outburst, and it took some time for her to get out of that condition. So first thing, it depends, it varies in between person to person. And the second one is the duration. But generally, if it is a duration in between few days, it's not going to impact that much. But if it runs into months, definitely it will. Because your sleep cycle will also change. If you are awakened here in Earth for 2 or 3 days, your entire mentality, your emotional condition, your psychological condition will change. And there in space condition, your whole biological clock is going to change. So that will definitely impact your psychological condition. Some will face in a more hard way, some will face that in a less hard way. But you will face that.
Another question from Senthil Kumar is, sir, can someone with a breathing issue also become an astronaut if they are subjected to so many problems?
No. It's almost impossible to become an astronaut with a serious breathing issue, because once your astronaut training would start, then you have to undergo through lots of medical checkups. It's a kind of journey. It's a kind of harsh journey for which you have to be mentally and physically well prepared. So unfortunately, someone with this kind of serious breathing issues might not make it to the final.
Priyanshu's question states, hello sir, I am a B Pharma student, undergraduate student. So what can I do in this field?
Excellent. Obviously, you will be having lots of things to contribute, Priyanshu. So after your bachelor's degree, you can pursue towards the master's, and maybe you can do some research. And during your research, there are huge need of precision medicine. There is a huge need of medicine that are dedicated entirely towards the astronauts, because the prescription for astronauts is quite different than that what we get as a prescriptional medicine here. So that is a completely different sector. And currently, this sector is in need of fresh pharmaceutical background scholars that could contribute in this kind of research. Recently, you can check this one. Recently, the University of Luxembourg and the Luxembourg Institute of Health, they have opened one translational program, and that translational program is known as the Medicine Biosphere. And under that Medicine Biosphere, there are different kinds of aspect of research where you can contribute in the field of space medicine and space pharmacology, to be very precise, and different kinds of drug specially tailored for the astronaut. So they have just started this initiative. So if you are interested, you can just go into that. You can simply search the Luxembourg Institute of Health, space medicine, space pharmaceuticals. You'll definitely be having that.
I'm a physics undergraduate student. What should I do next for exploring the field of space and this field?
If you are a physicist in nature, then definitely you can directly contribute to the astrophysics or astronomy itself. Also, you can contribute in the space radiation process, and you can help space biologists to understand the different physical and chemical aspects of radiation, depending on which a space biology expert or a space medicine expert can think of different kind of biological problem that those conditions are going to take place in an astronaut's health. And obviously, without your help, biologists cannot figure out the physical aspect of these conditions. So again, this is pretty much amalgamated in nature. So it's not like that if you're from physics, you can only be the person to contribute here. If you are from physics, you can contribute a part, and from that part onwards, a biologist can take care. So this is a kind of joint venture. That's why this is an interdisciplinary approach.
Alan has another question. Alan, you can go ahead.
So, for an astronaut in space, in his brain, the CSF, how will the absence of gravity affect the brain and the CSF and his health?
I'm sorry, I didn't get that question. Could you please repeat one more time?
So, in the brain, there is CSF, right?
Right, cerebrospinal fluid. Yeah.
Yeah. How does the absence of gravity affect that and the function of
Okay.
brain?
Got it. Obviously, so the most crucial thing that would happen is the CSF leakage. This is known as the CSF leakage. Why? Because under the microgravity condition, okay, let me tell you the basic biology first. So the cerebrospinal fluid is typically lined by a particular cell known as the ependymal cells or ependymocytes in our CNS. But under the microgravity condition, then these ependymal cells or the ependymocytes, they usually loses their structure and their integrity. And due to the loss of the integrity and the structure, there will be a huge risk of CSF leakage. And the CSF leakage can be really, really life-threatening condition.
Okay, sir. Thank you.
Welcome.
Okay. Uh, Chaudhary Shad Khan has another question that says, what is the difference between space medicine and normal medicine?
So in normal medicine, you are going to analyze all the pathological condition of a patient, and you can prescribe the precise drug, and everything will happen in earth condition. But in space medicine, you are going to prescribe the medicine for astronaut itself, because they are going to face something which is apparently absent in earth, like the microgravity, like the huge temperature fluctuation, radiation. These are literally absent in earth. So those medicines will be pretty much tailored. Those medicines are pretty much specific, and those medicines are properly made. So that's the basic difference in between the space medicine and normal medicine. Space medicine is the one step up of the normal medicine, which is pretty much tailored for the astronauts.
Lakshmi has a very career-specific question that says, which subject is best to contribute in space technology and space science in ISRO BSMS integrated program?
See, if you are going to be, it depends. If you are going to be a space biologist, then you can be a part of any BSMS program in molecular biology, and then you can continue from there. If you are a physicist enthusiast, then you can do the same way, but in physics. If you are a chemistry enthusiast, you can do the same thing in chemistry. So it hardly depends. Whatever the field you are going to take, that will somehow contribute to the field of astrobiology and space medicine. Because I would like to say this, that astrobiology, space medicine, these are the subjects that are still in their childhood. And these subjects are pretty open to accept each and everything that you want to give. So regardless of your career field, regardless of your stream, you can contribute to this field. And that these fields are more than happy to take that. Excuse me.
Samarjeet has another questions that says, is space medicine much costlier than normal medicine, sir?
Actually, if you're asking me in terms of the program, the learning program, or the medicine itself?
I think just the medicine in economic terms.
Okay. Yes, because these space medicine stuff, they are not normally available. Okay, both. So it's space medicine stuff, they are not normally available in the market. So it's not like that, okay, you are having something, you are going to get one Calpol. But here you cannot do that. It's pretty much limited, and it's entirely governed by strict government rules. So only the astronauts are legally able to get that. So it's not found in open market. And for the career course, there is no straightforward space medicine course. First, you need to have a bachelor's degree in medicine, then a master's degree, that may be MD or MS, and thereafter, you have to specialize yourself. As of now, in some certain universities, certain medical colleges, where you can take space medicine as your special consideration, and then you can go towards that. Because to be very honest, it's from the financial standpoint that if you are a doctor of any general stream, if you are a medicine doctor, if you are a orthopedic, if you are a cancer specialist, you are going to have lots of patients here in clinics, in hospitals. But if you are a space medicine expert, then maybe once in every 2 or 3 years, you're going to have one patient. But definitely the government will recruit you and you will be in the panel. So that prestige that dignity is something else. But on financial standpoint, it's little bit different.
Right. We have reached the end of Q in questions. Do we have any more questions that people want to raise their hands and ask themselves directly? Seems like, okay. Seems like there's not. Okay. Thank you. Thank you. Thank you so much, sir. Thank you, everybody
Thanks
else,
to you.
for asking so many great questions. Thank you, especially to you, sir. It was an absolute wonderful treat of a session to watch. We will end with our duties. We will take a few pictures. If you can all open your cameras, if you're not in opposing positions, we'll take a few pictures.
Thank you all for your time, for your patience, and thanks to the Propagation Institute for inviting me for this.